So just one moment when I get PowerPoint all squared away. Okay. So hello, welcome. Um, my name is Nathan Klaus. I'm a technical architect with Invista Corporation here in the USA, headquartered in Carmel, Indiana. I'm a business applications MVP, and I've been working with AX for 12 years, give or take. Um, and I really specialize in various integration technologies around F&O, not so much F&O, just F&O anymore. And I'm really passionate about application delivery, code management, handling um, complex modifications, um, sort of all around that stuff. And also I write on various topics at my blog at atomicax.com. My email is right there on screen, and my Twitter handle if you'd like to get a hold of me. So let's go ahead and dive right in. So this will be Dynamics 365 Finance and Operations, Git and ALM, how to deliver more faster. Before we get started, I'll reference a lot of other people's materials. I've got 3 slides at the end with all references to everything that I've talked about, with more technical details if you really want to get in and do it yourself. If not, we're going to talk about a lot of different topics, but I just simply didn't have time to dig into all the technical details I'd like to. So, but others have written about it for me, so we can certainly use that. But we'll be talking about what is source control, sort of philosophically. Hop into some Azure DevOps basics, how to get started with Git, some of the automation and action available options related to Git, as well as YAML, ATL, systest, if you're unfamiliar with those frameworks, and then at the end we'll have a Q&A. So first, let's sort of just dive into, what is source control. So if you have been with AX since it's been called AX now, finance and operations. When you think of source control, you typically think, oh, it just tracks and manages my code. That's all it really does. It might do some other stuff for my functional consultants, or my solution architects, or my end users. And really, we have 2 options in F&O for source control. That's TFVC, commonly known as just TFS, or Git. And Git is available via GitHub, Azure DevOps, and GitLab if you're familiar with GitLab. But ever since Microsoft has really started investing heavily in F&O, we've had sort of a shift in how we manage stuff and manage our work, because we're not just delivering software. This isn't just software development where we write a bunch of code and it just goes out the door and we never hear about it ever again. And again, this isn't software delivery either, because F&O is very complex and integrates with a lot of other things. So we have to sort of make the transition away from just the software development lifecycle to the application development lifecycle. So we're delivering an application and a solution, not just throwing code out there and hope it works. So we sort of have to make this transition from just code management to what source control really can do for us in F&O, and that's manage, plan, create, verify, package, secure, release, configure, monitor, and protect our application. So current state, we cannot do all of those inside Azure DevOps. Some of that is handled by LCS. There are APIs available inside LCS to do some of that stuff for us, but we're still interacting with LCS. We can't directly deploy a production environment from a build pipeline in Azure DevOps like you might be able to do with like a C# web app or something along those lines. But the story around this has gotten much more more robust. We have a lot more features, and we sort of need to play catch up and start using some of those features for our end users. So when we're talking about TFVC as our source control system, this is a very watered down slide. I'm not a fan of TFVC, but the one thing I hear when I say, hey, let's start using Git, is people say, well, TFVC is supported by Microsoft. Yes, it's technically true. Microsoft will support TFVC it's a product that they make and still provide support for. That doesn't necessarily translate to they will provide support for your finance and operations implementation if you're having issues with TFVC. They verify the product works and doesn't have any bugs. They don't necessarily provide support specifically on how you've implemented it. So that's yes, it's supported, but it's more of a like technical bullet point than anything else. Um, Next, it's push based, so you have to manage all of your change sets. If you've got a large team, let's say 20 developers on one project, you've basically made a new job where it's one person's job to manage all of those different pushes and make sure they go to the different environments from all your different developers all at one time, which can be a full-time job, sometimes even more than a full-time job. Next, branches last forever. When you set up a branch, it's either you need it or you don't, and typically you need it and just keep it around, especially in AX 2012. And that makes these branches monolithic, which you just sort of drag these things around and have to keep maintaining them, even though they may not be doing anything for you. It's part of your maintenance plan to make sure everyone's up to date, which sometimes it's just work for the sake of work. It doesn't really get you anything. Next, when talking about Git, the main pushback here, well, Git isn't supported. Well, yes, it's technically not supported in finance and operations by Microsoft, but Microsoft uses it internally. They've gone on record as saying that, and I think if it's good enough for them, it can be good enough for us. And Git is just more of a modern version system. It just sort of keeps track. It's if you're a C# person, you probably used Git. If you're making the transition from C# to X++, or maybe you're going to do both, that can be a challenge for some people just to wrap their head around how TFVC works, because it can be a little bit goofy at times. Git is pull-based, so that means we create a workspace for you. You do your work, and then we pull all your work in. We don't have to manage individual change sets. And either your work is taken as is, or we provide feedback, you make some alterations, and we try again. And branches are short-lived. So we'll get a requirement. Let's say we need a new data entity. We'll make a new branch for that data entity development. You work on it for 4 hours. Say, yep, I'm done. Here's my code. Here's my pull request. A more senior resource reviews it and says, yeah, looks good. We'll take it. It goes into the main branch, and then it goes up. It ships with the next release, whenever that next release is. So for me, that story is just more natural for the way that we implement and develop software, either whether it's implementation or even just after go live support or continued enhancement for your end users' needs. This is an example of a typical TFVC branch structure inside AX 2012. So here I'm developer 1. I've committed a change. Now I need to merge that change, that single change set, up to dev release for whatever this might have been. I have to manually merge it here, and then here, and then here. And let's say no bugs were found. It worked great. It gets released to production, it gets deployed to production. But that's sort of, I'm half done at this point, because I've got to manually merge that back to all my other developer branches, so all my other developers get the same thing that I just did. Which it's a small thing when you're looking at a single change set, but if you've got 50 change sets in a day, your work quickly adds up for all this just code maintenance to make sure everyone's running on the same version. Next, this is what you might see in TFVC with FNO. It's less complicated, but you still sort of have a similar problem where I might write something down here in the dev branch. It needs to be manually merged up to trunk, merged up to release, and then deployed. And when you look at the TFVC conceptual diagram from Microsoft, you can sort of see the issue that I'm getting at in that when you've got your main branch, so it goes all the way along the top, and if you'll look at the arrows pointing off to the right-hand side of the slide, that means that branch goes on forever, which is what you would expect from a main branch. But then when you get into servicing and hotfix and release, you can see I've got 4 branches that do basically one thing, and I've got to maintain 4 things to get my one thing, which is my release. All I care about is my release. And that can just become a lot of extra work that doesn't really get you any value. Next, if you look at the Git sort of conceptual diagram from Microsoft, you can sort of see along the top, we've got our topics. A topic can be whatever you want it to be. It can be a single requirement. It can be a set of requirements. It can be a hotfix. It can be a bug. You sort of define what that topic is, and you're sort of incentivized to keep that topic small because you create a workspace for that topic, which is a branch. You assign work for that branch. Say, hey, I need to do data entry that does X, Y, and Z. Someone works on that, they deliver your data entity, and then it goes back into your main branch or master branch, the green line in the middle. And then when the next release comes out, it just ships with the next release. So it's really, small change sets that amount to, minor features or bug fixes here or there that amount to when you actually get to your release. Let's say you release bi-weekly. A lot of different things can go in there. You're delivering stuff a whole lot faster than typical waterfall SDLC where you gather requirements, bunch of stuff happens over years amount of worth of time, and then here's your solution. But real quick, I don't want anyone to think I'm just sort of trashing TFVC. TFVC has a lot of cool features that I don't see get used a lot. So if you're interested in taking TFVC sort of the next level, I've included some things you'll want to check out, which are shelf sets, gated check-ins, and policies, along with some links for how I typically would set up my projects, and just some of the benefits that you get from those. But Git also has a lot of good things with it as well. So Git will allow you to source control a single folder. That means you have to move your projects into that folder that you have under source control. So you can do that per package inside your local packages directory, or you can just do it over an entire local package directory instance. Really just however you want to work, however you want to manage your projects. If you want to have your projects be package-based, that's fine. If you want it to be instance-based, that's fine too. Additionally, you can work offline with Git, so you don't have to have an active internet connection in order to continue to work. Now, I don't think that's such an issue, but when Git came, was coming around and sort of growing up, that was. But again, if you're on a flight and you want to, you have a VHD that you can use, you can work, get stuff done, commit it, and then when you land and have internet, you sync all those changes back up. And Git doesn't really care how or when you did it, just the central remote server gets those changes and it just accepts them and records them on your work items. Next, the sort of fundamental change is this branching per item or per requirement. So we don't have to manage change sets anymore. We're managing branches. That comes with both a positive and a negative. When we're managing just a branch, everything inside that branch gets taken when we pull it. But that means anything in there, if there's something that you didn't want to include, it's coming with anyways. So you got to sort of pay attention to that and plan ahead. Conversely, if let's say you have a requirement that took 5 change sets, I don't have to merge 5 change sets like I would in TFVC. I just say, all right, well, here's your branch with 1 or more commits in it. I'm going to take the whole thing. Just as part of the basic life cycle of changes inside Git, we get automatic reviews, and those are handled by pull requests, and we'll talk about that more in a little bit. But when you create a pull request, you say, hey, my code is done, it's ready to be checked in, and it would go to someone to review it to accept that pull request. That may be a more senior resource or just another developer who didn't develop the code just to make sure no one is being a bad actor in any way. But here's where we get into why I think Git is better. It's more modern. It matches how things work in the real world. You typically don't get a change that says, I want this massive sweeping, set of changes across my entire F&O instance. It's, I want this report to look like this. I want to add 3 fields to my customers. I want to have a data entity that does this. Or this data entity doesn't work the way I want. I want it to do these other things. And those are individual requirements that we can make a branch for. And then potentially, if we have developers available for each one of those changes, they get their own branch, they do all their work. And in a week, we've delivered 5 things rather than TFVC, where we might sort of stagger them one after the other. So it's more quote unquote agile. And really, just for me, meeting requirements one at a time is really important. This opens up more tools, automations, and actions that are available inside Azure DevOps. So when we convert to Git, really quickly, if you're using TFVC and you want to switch, it's really simple. Create a new Git repo inside Azure DevOps, make a new branch, copy your code over, add a .gitignore file, relocate your Visual Studio projects, and do some basic cleanup with a pull request, delete the old branch, and then you lock TFVC. And if you're interested in more detail on that, I wrote an article on that whole process and actually moved some code from a private DevOps repo into GitHub, which is now free and open source. So you can check out what that looks like as well. When converting to Git, you sort of have to convert your brain to Git as well, because we're not doing change sets anymore. We're doing branches. So everything that happens in there goes along for the ride, whether or not you want it to. So you just have to change how you work, change how you think, plan ahead. And it's just sort of the cheesy one-liner here. You know, we're pulling together rather than pushing alone. So when looking at when to commit, you know, as a developer, what would my experience be like? You know, we've got this new requirement called the requirement 1. So my tech lead or my tech arc will create a branch for me to work on requirement 1. I can go ahead and commit as many times as I'd like. Those are the green arrows. And then once I'm done, I say, hey, I'm done. We create a pull request, and that would go back up into main. And then we can get rid of the requirement 1 branch. Some of the more complex examples of a branching strategy is this one right here. So I sourced this from a post on nvie.com. But you can see you can sort of do, I don't want to say you can do whatever you want, but you can get more complex with how you manage your branches and how those interact with your master and release branches. So it's much more flexible than TFVC. And since we're managing branches, we don't have to worry about chain sets anymore. We can do a whole lot more stuff because we don't have to manage, you know, individual grains of sand, which would be our chain sets. We're just managing, you know, entire sand castles and moving those around, which would be our Git branches. So real quickly, you know, what is a pull request? A pull request just says, you know, when you've got a branch, so just lets everyone know you think you've done your work. You want to discuss and review any potential changes, and then have that be accepted into the branch you're pulling it to. When to create a pull request? You know, obviously, when development is done, ideally when your test cases are created and it's been tested. You know, that can be difficult. If you're a consultant and users typically don't want to pay for that additional cost of your test case development, but the way that Microsoft is now shipping FNO with 10 updates a year, it's making a whole lot more sense to do that because we can just run automated testing when a new version comes out and say, yeah, here's what this looks like. Everything passed, you know, we're fairly comfortable. Everything will work when we get to 10.0.21 or 10.0.22, whatever the case may be. But still, you know, that still can be a hard sell to get budget or time to do that. But it will start paying off, and it has paid off for some of my clients. You know, real quick, how to create a pull request. This is one of the things I just wanted to highlight, just how much more friendly Git is relative to TFVC. You can create a pull request inside Visual Studio, DevOps, GitHub, or GitLab. Just in Visual Studio, there's a button, new pull request. Inside Azure DevOps, this is inside a web browser. I can do this inside a web browser. I don't even need Visual Studio, which can make managing some of this stuff a little bit easier. If you only have Visual Studio installed on, let's say, development VM out in the cloud that's off, and you just need to quickly create a pull request, you can do it via the web. So just much more flexible and lightweight, so we can get more done. Um, what pull requests allow you to do is add in some additional actions or changes or automations around whatever it is you're pulling. So you can you can do a build as part of a pull request before it gets to a review. So what that means is, let's say I have a developer who developed, let's say, a new table and form, um, and a data entity that goes along with that. Let's say they forgot their staging table for their data entity. When they committed everything and they do a pull request, they would build that and say, hey, we're missing, missing these artifacts, so I can't complete a build. Cancel the build request, have it go provide that feedback back to the original developer and say, this failed to compile check. You need to, resolve these issues. You can also have automated testing and builds included in that as part of that pull request. And what this opens up is the idea of what I call the quality bar. So what state is the code that you're accepting as part of that pull request or reviewing? Is it if? Does it just compile, which is obviously good. We need our code to compile. But does it compile and pass unit tests, or as well, does it pass ATL tests as well? So we can get into a real high degree of code quality code delivery just by adding in some additional testing, and this all happens before a more senior resource would review it. So let's say I'm a developer, I make some changes, I I commit it. That would kick off some style of quality bar checks, whatever we want to have configured here. I do a pull request, and that activates even more stringent quality bar tests to make sure what it is that I'm delivering won't break anything. And really, what that looks like, again, we're back to requirement one. I've got my commits here. And on this particular branch, I've enabled continuous integration. So every time I do a commit, behind the scenes, it'll kick off a build and do just a code compile check. It'll just compile my code to make sure I'm committing all the artifacts that I need to. And it'll send me an email with a report of, here's your build report. It failed because, you forgot your staging table, or it built successfully, nothing really to report. And once we've done that, we can create a pull request. And then as part of our pull request, we can add in all sorts of various automations and just tests to make sure that what is being included in the pull request meets a certain quality bar. And you can define what that quality bar is. So real quickly, when you've got a pipeline, you can turn on continuous integration in any pipeline. It doesn't have to be Git or TFVC. It can be any pipeline. So you can go to triggers, select the schedule, and then filter on the branch if you want this to be branch specific. But check that enable continuous integration checkbox. And anytime there's a commit against that specific branch, it'll kick off a build and let you know what happened. An example of a pull request, so I'll speed through this fairly quickly. I'm pulling feature one into main. You can see here at the green arrow, I've got an X++ class build pipeline queued. So right now, I'm just waiting for the result of that build. I've got three total checks on this pull request currently. It automatically merged all my code for me, which is nice. If it couldn't do that, we'll review what that would look like. You can see I've got my linked worked items at the red arrow in the bottom right. And right now, this is not assigned to a reviewer because we haven't made it past our quality bar checks to make sure this merges, this compiles, this passes, X, Y, and Z tests. This particular build pipeline I set up with, it has to pass a build in order to be considered for a pull request. It has to have work items associated with the commits. And additionally, this is just an optional one. Code coverage, the code coverage result from my classic pipeline is checked here as well. So next we'll cover an example of just what merge conflict would look like and what the experience would be. So, I'm committing feature 2. I'm pulling that from feature 2 branch into main branch. I do have a required check that was successful. I do have work items linked. But if you look down here, I've got some merge conflicts. And now I'm going to have to manually resolve those merge conflicts. I do this by clicking on the conflicts tab, but I just wanted to call out the reviewer is now assigned to me. In this instance, I'm the only user, so I had to go back to me. But it would go to either the developer who created the merge conflicts or a more senior resource to resolve those merge conflicts. But we failed some tests. We can see what those tests were, and now it's going to a senior resource to review, disposition, and potentially send it back to the original developer. So, real quickly, if you're familiar with this sort of looks like an upgraded version of what you'd get in Visual Studio. But you can see I've got my conflicts on the left, my specific errors down along the bottom with the green arrows, and then I can take left or keep target. I can also do a manual merge as well. But you can sort of see feature 1 and feature 2. If there's an info log in a main method on runnable class 1 are incompatible. So when I look at the sort of the workflow for this, I've got my requirement 2 commits with my continuous integration builds. I've got my pull request, and now I've got a conflict. So I've got to decide what I'm going to do here. And this all happens prior to making to the main branch. So yes, we have some issues, but they're being created and called out before they make it into our main branch. So no end user would potentially see this, and it's sort of kept on the back end for us to resolve rather than have it be visible by an end user. So next, when talking about different branches, you can talk about new and sort of different ways to manage your resources. So let's say I've got 2 developers, and I need to deliver what's on my screen in a particular time frame. So time is just an arrow that's pointing to the right along the bottom. I could have developer 1 work on the items in the boxes in blue, and you can see they don't overlap. So I, make a branch for requirement 3. They commit it. I create another branch for bug 1, and they commit that, and it gets pulled and accepted. And then, the items in the green box, that could be another developer working on other things. But you can still see, a branch per requirement. Those are typically short-lived, and then we pull it up into the main branch and just sort of carry on. Additionally, you can have one developer flip between branches. This gets into some more technical considerations because X++ doesn't exactly like the way that Git manages stuff, so you might have multiple versions, so you'll have to use multiple versions of files related to different branches, so you have to use symlinks. There's a link at the end where we discuss how to manage that, but just call that out. But really, you want to try and keep it 1 requirement per developer per amount of time, and then when they finish that, they move on to the next thing. If there's a bug in the original, like let's say there's a bug in requirement 1, we can just make a new branch to resolve that bug in requirement 1. It doesn't necessarily have to go back to the original developer. So it's allows you to play mix and match with developers and bugs and just deliver more faster. Next, we're going to talk about YAML. So this is a high-level slide. YAML is really cool. So it's a human-readable data serialization engine. What it means is you can use this to build a pipeline, whether it's a build pipeline or a release pipeline. You can add it to source control, and then you can tell DevOps to say, hey, I want to build a pipeline from this artifact in source control, so you can create your pipelines on demand. So you can basically create them once and recycle them throughout all of your different branches. And you don't have to keep on building new pipelines. Like for TFBC, you build your like pipeline for dev, you build your pipeline for, let's say, trunk or main, and then your pipeline for release. So you can just add it once to source control, and then it'll just recycle it and use it as many times as you'd like. So next, we sort of briefly touched on testing, and I wanted to run through the two types of testing systems that we'll be using when working with X++, and that is systest and ATL, or the acceptance test library. Systest is automatically discoverable. It's already built into the template. You just have to tell it which DLL to use. And systest is based for unit, best used for unit tests. I'm going to walk through a couple examples. Similar with ATL, it's just more component or simple integration testing, and we're going to review those real quick. So first, this is what an example of a systest class would look like. This is pulled right from Microsoft Docs. Along the top, we have a class called FM Unit Test Sample, which extends this test case. This is an example of a method that runs a test, and at the very end, you can see this. We have this dot assert equals. The expected total should match the actual total calculated in this. And if it does, then that test passes. Otherwise, it fails. And similarly, this is a more relatable test. We're doing a validate field on a car class based on the number of doors. So, can a car have -1 doors? No, we would expect that test to fail by design. But then, can a car have 4 doors? Yes, it can. That should be a passing test. So next, this is what ATL would look like. An ATL is very powerful and very easy to work with, sort of once you wrap your head around the Fluent model of how it works. So real quick, this is again pulled from Microsoft Docs, so you can go check this out. There's a link at the end of the presentation for where to find this. We have in the blue box, we basically set up our tests. We get a default warehouse based on the company we're in. We'll create a new item based on the warehouse that we're in. We adjust the inventory for that item to be 100 in our default warehouse. Next, we create a sales order. Next, we add a sales line to our sales order. We set the item on that, and we set that item to have a sales quantity of 10. Next, we reserve 3 against that sales line that we just created. And then finally, we'll take a look at what the result of all of that was. So we should have a -7 with an on order, because we have to flip the sign, and then -3 with a status of reserved physical. I'm going to zoom out a little bit. This kind of stuff in 2012 specifically was unimaginable. To create a item, find a default warehouse, create an item, adjust it in, create a sales order, create a sales line, reserve on that sales line, and then check the values. I can't think of a way that you could do that in 2012 without at least 200 lines of code. And here we're doing it. We almost have as many comments as we do lines of code here. So ATL is super powerful for when you need to generate test data and build stuff in a known state and then test against that known state. So next, when talking about tests, we have different pipelines available for builds, and that limits how we can use those tests. So like if you're using the serverless builds, which is the free option from Microsoft, that will do a simple build. It's Azure hosted, but all it will do is a build. It won't do any of the more complicated tasks, like do a database sync to make sure people aren't changing data types on your tables, which can happen. It happens maybe once a year for me, but it catches it and then we resolve it. So the serverless builds cannot do unit tests or ATL tests as well. But when you get into a dedicated build server, it doesn't necessarily have to be hosted in Azure. There are other options. When looking at the infrastructure side with Azure hosted, that's all orchestrated through Azure DevOps with pipelines. You don't have to do anything. You just have to configure it and basically tell it what to install, how to do the build, and then you review the result. If you'd like to do a cloud-hosted environment, that's provisioned by LCS, hosted in your Azure. And then there's a build agent from Azure DevOps installed on it, and it just does whatever Azure DevOps asks it to do, which could be a simple build, database sync, running sys tests, unit tests, restoring databases. It can do all sorts of things. And the third option is really either on-premise or other. So you can modify the VHD from Microsoft to build your own virtual machine. You can host it wherever you would like, and you can do these builds on demand. So it could be in Azure, it could be on-prem. It's really up to you. If you're interested in finding out more about setting up a build pipeline where we dynamically create a machine, a VM to do your builds, whatever that build may be, check out Andrea's article right there. When looking at test classifications, there are two that we're most interested in really on the tech side, and that's because we have to write code for them to work, and that is sys and ATL, the numbers 1 and 2 there. So you can sort of see what their quote-unquote sweet spot is, and how we want to use them. So when we're writing code, those are the kind of things that we could test. But then if we need to start getting into more functional or user-based testing, we would want to use RSAT. RSAT is a huge topic, which I'd love to talk about, but I think I need a whole day to cover everything. But you can sort of see based on the developer focused test types and the user test types, we have pretty good coverage across that whole pyramid for what it is that our test will need to do. So we just have to start writing and integrating our unit tests and component tests using sys and ATL to really start, driving value and getting rid of end user testing on, common stuff. Next, we're going to cover automated release. This has been out for a while, but I just wanted to touch on it real quick. You can release from Azure DevOps to LCS or to UAT. Unfortunately, production is not currently supported. But inside DevOps, you can set up a pipeline to build, and then after the result of that build, create a release pipeline to send your deployable package over to LCS. You can see it right there in LCS. It's easy to select from. You don't have to download it to your machine and then re-upload it. The only call out here is if you're doing this a lot, you will have to manually periodically clean up LCS, just because there's no built-in functionality to delete packages that are more than 60 days old with no reference to an environment or this, that, or the other thing. But still pretty easy. So as you're creating builds, they can just be sent over to LCS and you can take them from there. Conversely, this is where we start to see a lot of value is we can start setting up release pipelines to release to a specific environment. Any standard environment in LCS can be deployed to. Production is not currently supported. But what that means is, here's an example of an LCS project. I have a client that has multiple standard acceptance test environments. I can deploy from a build with a release pipeline to any of these on any schedule that I set. Really any of these will work. And it'll send emails out, and I can orchestrate, when this would happen. Let's say every Friday night I want to deploy a new build, and I send an email, say, here's what's in that build. I can do that against all my standard environments, but not production. Sort of lastly, if you want to find out more about how to configure this type of pipeline, there's a link here from Andrea for how to get that all configured. So now when we sort of take a look at all of that stuff that I've just talked about, we look at, and I call this the new feedback loop. This is, again, a slide from Microsoft. This is more C# centric, but it can apply to us in a lot of areas as well. You have your engineer, working with Visual Studio using Azure repos like Git, and using test plans like sys and ATL in conjunction with pipelines, and that will build, build, test, orchestrate, and deploy some of our apps, which would be finance and operations, using LCS. And then inside LCS, we can get feedback as to what's going on in our apps and then go back to our engineer and our Azure boards to resolve. So it's this infinite loop of, we deliver high quality code, we monitor it, we get feedback, as things change. Let's say we added a table, that table now has 1 million records, and we need to add some additional indexing. We'll get that feedback and address it, and then go right back into Visual Studio to add that index, commit it, do a pull request, and then complete the circle again. So another way to look at this, and this is how Microsoft does it and how they deliver the product, is to release, deploy, operate, monitor, plan, code, build, test, and then just keep that going forever, because that's how Microsoft delivers to us. We get 10 updates a year, and we have to keep track of sort of all of our changes. Sometimes they do introduce breaking changes, and we have to be prepared for those. But really, it's less just get software out the door and we never see it again. To more, we're going to have to continue to manage the stuff as Microsoft keeps on providing updates. So we've covered a lot. Here are all the sources for various things that I've talked about in today's presentation. These are much more deeper dive articles from myself, Adria, who's a fellow MVP, and Paul Heisterkamp, who's also a fellow MVP, as well as Microsoft Docs. So if you'd like to know more and start getting your hands dirty and setting this up for yourself, here's a lot of good documentation on how to do that. But lastly, just sort of in summary, I think Git can really help you take your delivery to the next level with automation around building, testing, and deployment. So thank you, everyone. Right after this presentation, my slide deck will be uploaded to my GitHub. So if you'd like to pick that up and take a look at all the links included throughout the presentation, feel free. Thank you. Did we have any questions?
Thank you, Nathan. This is Rachit. The session was really a good beginner's guide for anyone who wants to embark on this Git version control. I know this is so much in an area of interest for every technical person. Everyone wants to use Git now for version control. So thanks a lot for sharing these insights. We have few questions. So first question is, the way we can link the change sets when we are using TFVC to the DevOps requirement, can we still do it in Git? Like when we do a pull request, can we link it to the DevOps requirements?
Yes, we can. And that's, it's optional. I typically set up that rule to be enforced so that when I commit something to a branch, it'll reject it and say, hey, I need to know what work item this relates to. And then when you do a pull request for all commits on that branch, it will pull in all of the work items associated with all those commits onto your pull request.
Right, that's a great benefit, because generally when we run a build, we need to identify which features or which bugs were developed or fixed as a part of that release. So that answers. Thank you for that. There is another question, like when we are using Git as our version control, does it impact the way our release pipelines are configured? Like there are some release tasks released by Microsoft to deploy the packages in tier 2 environments. Does it impact if we use TFVC or Git in our build?
It does. I believe it's the very first step where you have to map your version control, where you're pulling your code from to build. So you'd associate that with Git. You only do one folder. And then I think it's step 4. You have to basically tell it where to find your projects and where to find your code, because now they're in the same place. But it's very minimal. I think Paul Heisterkamp actually wrote an article on how to find that, and I believe that was one of the linked articles that I had near the end. But otherwise, the build pipeline doesn't specifically care, so long as it knows where to find its projects and where to find its code. You could host it in Subversion if you really wanted to. I mean, please don't. But the pipeline doesn't care where it gets the code from, just as long as it consistently can find that code.
Perfect. Thanks for that. And just one more last question, like, are there any best practices or guidelines around naming convention for these branches which developers create when they do a pull request?
Not really that I'm aware of. The branches themselves, when you make them, should be tied to a work item. And Paul actually wrote an article on that as well that I referenced. When you make a new work item, you can just say make a new branch for this work item, and that takes your branch,
Yeah.
whatever it's called, and ties it to that work item. So you don't necessarily need to know branches or naming conventions. It could just be branch work item 154. It doesn't
Right.
really matter because you put the two together and then you can't separate them.
Cool. Lot of comments about the appreciation of this session, Nathan. Everyone is liking this. So thanks a lot for coming on a Sunday and giving this session and sharing your time with us. We really appreciate it.
Yeah, no problem. And if you have any more questions or follow-ups, I'm on Twitter, so feel free to send questions.